Hello, my name is Jacob Pushy, and for this advanced concept presentation, I'll be walking you, the audience, through every step that is involved in generating acetyl-CoA, coenzyme A, from pyruvate, and for this presentation I will focus on any cofactors needed and show how this process is reset at the end to allow for other pyruvate molecules to bind. So, to begin, for starters, the net reaction of pyruvate to acetyl-CoA involves the addition of a coenzyme A and, in addition, the removal of carbon dioxide, and also is catalyzed by the enzyme pyruvate dehydrogenase complex. The reaction is shown here. Pyruvate plus SHCoA plus NAD yields acetyl-CoA plus NADH plus CO2. And that is the pyruvate dehydrogenase complex. The reaction is catalyzed by a group of three enzymes. These enzymes being E1, which is pyruvate dehydrogenase, E2, dihydrolipol acetyltransferase, and E3, dihydrolipol dehydrogenase, and five coenzymes, a group of five coenzymes, TPP, lipoate, FAD, NAD, and CoASH. The mechanism involves the following steps. First, E1 catalyzes the addition of acyl group from pyruvate to the TPP group, removing carbon dioxide from the pyruvate molecule. Secondly, the acyl TPP transfers its acyl group to the lipoate group and then is catalyzed by the enzyme E2, which then releases a molecule of TPP in the process of this reaction. Also, in addition, it catalyzes the addition of the acetyl group from the acyl group to form acetyl-CoA. Thirdly, in this process, the lipoate group is reduced due to the addition of two hydrogen groups by the E2 enzymes. The enzyme E3 then catalyzes the removal of the two hydrogen and catalyzes the addition to the FAD molecule to produce FADH2. Then the FADH2 is oxidized back to FAD to form NADH plus H plus hydrogen. After this, the FAD, TPP, and lipoate group are recycled back from another set of reactions. So the FAD, TPP, and lipoate group are recycled back from another set of reactions that we've discussed previously. The acetyl group is transferred back to the reaction mixture during the citric acid cycle. And finally, the carbon dioxide produced is removed from the body as a metabolic waste product. So that is the process in about 6 steps. So firstly, the E1 catalyzes the addition of the acyl group from pyruvate to the TPP group, then removing carbon dioxide from the pyruvate molecule. Second, the acyl TPP transfers its acyl group to the lipoate group and is catalyzed by the enzyme E2, releasing a molecule of TPP in the process. It then catalyzes the addition of the acetyl group onto the acyl group to form acetyl-CoA. And thirdly, the lipoate group is reduced due to the addition of the two hydrogen groups by the E2 enzymes, and the enzyme E3 catalyzes then the removal of the two hydrogen and catalyzes the addition to the FAD molecule to produce the FADH2 we discussed, and then the FADH2 is oxidized back to FAD to form NADH plus. And then after this, the FAD, TPP, and lipoate group are recycled back to another set for another set of reactions. The acetyl group is transferred back to the reaction mixture during the citric acid cycle, and then finally the carbon dioxide that we have produced is removed from the body as a metabolic waste product. And so, guys, that is my presentation on the steps involved in generating acetyl-CoA from pyruvate, with a focus on any cofactors needed, and also a description on how this process is reset at the end to allow for any pyruvate molecules to bind. Thanks, guys.